Hello everyone, welcome to a revision lesson for analytical geometry. So as an introduction, I'll just read through the notes and then try to do a few examples, right? So analytical geometry works with the Cartesian plane and with algebra to define points, lines, and shapes, right? This topic is also called coordinate geometry. And then it starts by talking about the gradient of a line. I'm sure we all know how to calculate the gradient by now. It is the change in y values over the change in x values, which is y2 minus y1 divided by x2 minus x1. A gradient is the slope of a straight line. It shows how steep the line is. The steeper the gradient, the bigger the angle it makes with the ground or with the positive side of the x-axis. Alright, so when the gradient is negative, we have a decreasing line, and when the gradient is equals to 0, we have a horizontal line, and when a gradient is positive, we have an increasing line, and then when the gradient is undefined, we have a vertical line. Okay, so if maybe you are calculating a gradient and then you see what the line is decreasing, and then by some reason it happens what you get a positive answer for your gradient, then you should know what something is wrong there. Okay, and then we also talk about parallel lines. Parallel lines have equal gradients, right? That is, if the line AB is parallel to CD, therefore the gradient of AB will be equals to the gradient of CD, right? And then we also have perpendicular lines, right? Perpendicular lines, they form a 90-degree angle, right? The product of gradients of lines that are perpendicular is -1. This means that the gradient of one line is the negative reciprocal of the gradient of the second line. So if the line AB is perpendicular to the line PQ, as we see in this sketch, the product of their gradients will be equals to -1. That is, the gradient of AB times the gradient of PQ will be equals to -1, right? And then okay, let us look at this example. The graph of y equals to 2x plus 1 is the graphs of the line y equals to 2x plus 1 and the graph y equals to 2x plus 5 are parallel because they have the gradient of 2, right? Notice on this line the gradient is 2, and then on this one the gradient is also 2. The only difference is that value of c, which is the y-intercept, right? The graph of y equals to 2x plus 1 and the graph of y equals to minus 1 over 2x plus 5 are perpendicular, because if you say 2 times -1 over 2, you will get the answer of -1, right? So because when the lines are perpendicular, the product of their gradients will be -1. Therefore these two lines are perpendicular, right? And then we also have the distance formula. The length of the side of the line AB is equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, right? You can also say, instead of x2 and x1, use letters. Maybe uti the square root of x at a minus x at b all squared plus y at a minus y at b all squared, right? I used to do that a lot because we avoid a confusion with which point is x2 and which point is x1, right? Let me quickly show you what I mean. So we have this distance formula. Instead of having it as x1 and x2, you can have it as AB is equals to the square root of x at a minus x at b all squared plus y at a minus y at b all squared, right? So mina used to write it like this because it helped ukuthi nginga sort of like mix up lama points where ungabe confused ukuthi which point did you choose as x1 and which point did you choose as x2. You can also do the same for a gradient. Let's say you want to calculate the gradient of m of the line AB. You can say y at A minus y at B divided by x at A minus x at B. Instead of you saying the gradient of AB is equals to y2 minus y1 over x2 minus x1, right? You can do this or you can do that, but then mina used to prefer this a lot because it helped ukuthi ngingaconfuse ama coordinates wami. I'll know ukuthi if I see y at A, I'll have to go to point A and see what are the coordinates there, right? Whereas with y2 and y1, you can either pick point A as y2 or point B as y2, right? So if you label with these letters, you can sort of like minimize mistakes or clear any confusions. Okay, that is just a tip, but then if you are comfortable using x2 and x1, it's fine. All right. You can also use the distance formula to find the coordinates of a point on the line using we can also use the distance formula to find the coordinates of the point. Let's say maybe you are given a distance with the line AB is equals to maybe 5 units, and then maybe you are not given maybe one of the coordinates. You can use the distance formula to calculate the coordinates if you are given the distance. Right, so let us look at this example. Okay, let us look at this example here. Right, so we have this example, but L is that point and M is that point, are two set of coordinates on the same straight line. They want us to determine the length of LM, right? So we know that we will have to use the distance formula to calculate the length of LM, right? So I'll say LM is equals to the square root of x at L minus x at M all squared plus y at L minus y at M all squared, right? So x at L is minus 5 and then x at M is minus 1. So I'll have minus 1, which is plus 1, and then this is squared, plus y at L is minus 2, and then y at M is minus 6. So I'll have minus 6, which is plus 6 all squared, right? And then I'll just punch this in my calculator and see what do I get. So I have minus 5 plus 1 squared plus minus 2 plus 6 squared. I get the answer is 4 root 2 units, right? Maybe if you write it in decimal form and round off to 2 decimal places, you'll get 5.66 units. Okay. And then the length of, now we are given the length of PQ, and then we will have to calculate the value of T. So the length of the straight line PQ is given as 2 root 5. The coordinates of P are these, the coordinates of Q are those, where we don't know the value of T, right? So we have to use the distance formula to find the value of T. Alright, so let us go ahead and do that. Okay. So the length of a PQ is, So we know what the length of PQ can be calculated using the distance formula, where we say x at P minus x at Q all squared plus y at P minus y at Q all squared, right? But then we are given this length of PQ, which is 2 root 5, and then we know what the x at P is 5 minus x at Q is 3 all squared plus y at P is 2 minus y at Q is T, which is what we want to calculate, right? So now to calculate the value of T, I'm just gonna square both sides and I'll get, if I say 2 root 5 all squared, if I say 2 root 5 all squared, I get the answer to be 20, right? If I just square both sides like this, 2 root 5 all squared, I'll get this to be 20 equals to 5 minus 3, that is 2 squared is 4, plus 2 minus T squared. And then now I'll need to solve for T. So 2 minus T all squared will be equals to 16, right? So this means that 2 minus T is equals to plus or minus the square root of 16, right? So 2 minus T is equals to 4. 2 minus T is equals to 4, or 2 minus T is equals to negative 4, right? So now T is equals to 2 minus 4 equals to minus 2, or T is equals to 2 plus 4 equals to 8, equals to 6. T is equals to minus 2, or T is equals to 6. Okay, and then we're done. So now can sort of look at this activity. For a line passing through these points, we can calculate the distance by using the distance formula, and then if PQ is equals to 5 units. Okay, so this questions for activity 1, they are the same or similar to these ones in this example. Alright, so we're just gonna skip. Alright, and then we go on to the midpoint of a line. Alright, so if you know the coordinates of the two endpoints of a line, you can find the point that is halfway between them. This is called the midpoint, right? So the midpoint of a line has the coordinates x1 plus x2 divided by 2, or instead of saying x1 plus x2, you can say maybe x at A plus x at B divided by 2, and then y1 plus y2 divided by 2, you can say y at A divided plus y at B divided by 2, right? So let us look at this example. So but if for a line passing through the 2 points A and B, find the coordinates of the midpoint of AB. So they do that by saying the midpoint of AB is equals to x1 plus x2 divided by 2, y1 plus y2 divided by 2, and then you pick which point do you want to make x1 and which point do you want to make x2. So they choose point A as x1 and y1, which is why they have 6 plus 3 divided by 2, and then they get 4.5, and then they have y1 and y2 as 6 plus 2 divided by 2, and they get 4. And that is how you calculate the midpoints, right? Or maybe you can be given the coordinates of the midpoint, and then we will be asked to find the coordinates of the end point, right? So like in this example here, the coordinates of the midpoint of the line AB are given as 1 and -4, and then you need to find the coordinates of A if the coordinates of B are these. So now you need to calculate the x coordinate of A separately and the y coordinate of A separately. So when the midpoint is given, x as the midpoint of AB will be equals to x at A plus x at B divided by 2, right? So we are given the x coordinate at B, which is 4, right? But then we don't know the x coordinate at A, right? But then we know the value of the, okay, let us sort of write this down. We are given the midpoint, the coordinates of the midpoint, and then we have to find the coordinates of one of the endpoints, right? We are given the coordinates of the midpoint, and then we need to find the coordinates of the endpoint, right? The coordinates of the midpoint of the line AB are given by 1 and -4. So our midpoint is 1 and -4. So the midpoint of AB is given by these coordinates 1 and -4. We want to find the coordinates of A, right? So in order to find the coordinates of A, we know when we calculate the midpoint, the x coordinate of the midpoint will be x at A plus x at B divided by 2, right? But then we know the value of this to be 1, right? So the x coordinate of the midpoint is 1, and then this is how we calculate that coordinate. So this should be equals to 1, right? And then we know x at B is 4. So we'll substitute 4 where we see x at B. 1 is equals to x at A plus 4 divided by 2. Therefore, when we solve for x at A, we will get it is 2 minus 4, which is -2, right? And then now we'll go on to calculate the y coordinate of A. So now we'll have the way we calculate the y coordinate of the midpoint. Will say y at A plus y at B divided by 2 is equals to the y coordinate of the midpoint. But then we already know the y coordinate of the midpoint to be -4, right? And then we also know the y coordinate of B is -3. So where we see y at yb, will substitute -3. So I'll have -4 is equals to ya -3 divided by 2. So ya will be -8 plus 3 is equals to -5, right? So now the coordinates of A will be -2, which is this, and -5, which is that. Okay, that is how we calculate an endpoint. And then this activity is exactly the same as the first two examples, right? The first one wants you to calculate the coordinates of the midpoint, and then the second one says if the midpoint is given, and then you need to calculate the coordinates of the endpoint, right? So yeah, they're the same. We'll just keep this one also, and then discuss the equation of a line, right? So when we're doing functions and graphs, we did talk about the straight line, right? We're saying a straight line is a line which has an equation in the form y equals to mx plus c, right? So if you know the gradient of the line and you know the y-intercept c, you can be able to determine the equation of a straight line, right? So I always prefer this form of y equals to mx plus c, but then you can also find the equation of a straight line using y minus y1 is equals to m times x minus x1 if you know the gradient and any point on the line or 2 points given. Okay, so I'll always go with y equals to mx plus c. That is what I prefer, but then feel free, if maybe you prefer this one, you can just go ahead and use it. But then I know with him, if I have this form, I'll just calculate the gradient and use any other point that is given to calculate the value of c. Okay, so yeah, that is a straight line. I'm sure like we all comfortable with a straight line. There's not much to it. It's also part of analytical geometry, so make sure you are comfortable with a straight line. Okay, and then what else is there? The inclination of a line, right? So now we introduce angles to gradient, right? There's a relationship between the gradient and the inclination of that line. The gradient of the line determines the slope, and the inclination is sort of like the angle between the ground or the positive x-axis and that line, right? So they have a relationship with each other, the gradient and the angle of inclination. So in trigonometry, we use the trigonometric ratios tan, sin, and cos. So to find the inclination of the line or the angle it makes with the x-axis, we will use the trigonometric ratio of tan theta. In triangle ABC, as we can see in this sketch, tan theta is the opposite side over the adjacent side, which is BC divided by AC, right? But then BC divided by AC is the change in y values, and then AC is the change in x values, right? So which is the gradient of AB? Remember, what the gradient is the change in y values divided by the change in x values. So if you say BC over AC, you are technically calculating the gradient of that line, right? So we can say that the gradient of AB is equals to tan theta, because it is opposite over adjacent, and the way we calculate gradient, we say change in y over change in x, which is just BC over AC. But then BC over AC is opposite over adjacent, which is why we are equating it to the trigonometric ratio of tan theta, right? So if you say tan theta, you will have BC over AC, right? Again, but then if you also calculate the gradient, you will have BC over AC. So they are the same, which is why we are equating them here. So another way of calculating the gradient, if you are not given the coordinates of the points, you can just use the angle of inclination, right? Or you can be given a gradient and be asked to calculate the angle of inclination. Notice that the angle of inclination cannot be negative or greater than 180. So it will always be between 0 and 180 degrees. Okay. So yeah. Let us look at this activity. Okay, let's just create space here. Okay, so Lanabati, the line AB is perpendicular to CD, which has a gradient of -4. Find the inclination of the line AB. CD is perpendicular to AB, and CD has a gradient of -4. Because they are perpendicular, we know what the product of their gradients will be -1. That is MAB For question 1, MAB multiplied by MCD should be equals to -1 because they are perpendicular, right? MAB is what we want to calculate, right? And then we know with the MCD, which is the gradient of the line CD, is -4, right? So if MCD is -4, it means MAB should be equals to 1/4, such that when we multiply it by -4, it will give us -1 because they are perpendicular, right? So we have the gradient of MAB. Now we can find the inclination, the angle of inclination theta of AB, right? So to do that, we will say we know what the MAB is equals to tan theta, right? But then this is 1/4 should be equals to tan theta. To find the angle, we just say shift tan to get tan inverse 1/4 is equals to, you can punch in your calculator, this will be 14.04 degrees. Okay, and then question 2, but determine the inclination of the straight line that passes through the points P and Q. So there we need to calculate the gradient of PQ, right, which is y at P minus y at Q divided by x at P minus x at Q, right? Y at P is 2, y at Q is 10, and then x at P is -6, x at Q is -3. So I'll have -8 over -9, right? This is 8 over 9, right? Now to calculate the angle of inclination of this straight line, I'll equate the gradient to PQ to tan theta, right? So 8 over 9 will be equals to tan theta, and then theta will be equals to tan inverse 8 over 9, right, which is 41.63 degrees. Okay, which is 41.63 degrees. That is question 1 and 2. And then question 3, Batini, but given the points A, B, and C, calculate the size of the angle ABC. Right, so let us sort of have a rough sketch of these points on a Cartesian plane. Okay. So the point A will be -2, -1. -2, -1 will be somewhere there, and then the point B is 5, 6. That will be somewhere there, and then the point 7 -2 will be somewhere here. Okay, so this is a rough sketch, not drawn to scale. Alright, so we have our mini triangle. So this is A, that is B, and that is C. So we need to calculate angle ABC, which is that angle there. Okay, so now to do so, we'll need to do that, we'll need to know maybe the value of that angle and that angle, so that we can use the sum of angles in a triangle. And yeah, so we have the points ABC, where A is -2, -1, B is B is 5, 6, and then C is 7, -2, right? So we can calculate the gradient of the line AB and then calculate the gradient of the line BC. Yeah? So MAB is equals to y at A, which is -1, minus y at B, which is 6, divided by x at A, which is -2, minus x at B, which is 5. So this will be -7 over -7, which is 1, right? And then there will be an angle of inclination here. Let us call it alpha, right? So to calculate the angle alpha, we'll say alpha is equals to tan inverse of 1, which is equals to 45 degrees, right? 45 degrees. So that angle there is 45 degrees. Okay, and then we'll go ahead and calculate the gradient of BC. MBC is equals to y at B is 6, minus y at C is -2, so we have +2. X at B is 5, minus x at C is 7. Right, so here we'll have 8 over -2 will be -4. Right, so now to calculate, calculating, so this line is decreasing, yeah? So it has a negative gradient, right? So now the angle that we need to calculate is the angle that is between the line and the positive x-axis, right? So this is the angle we want to calculate. Let us call it angle beta, right? So now angle beta is equals to tan inverse of -4 plus 180. The reason that I add 180 is because if you say tan inverse of -4, this is minus 75.96 degrees plus 180. So this is a negative angle. Remember, we said our angle of inclination has to be between 0 and 180, right? So the reason why I add 180, I'll have a positive angle of 104 degrees, right? So 104.04 degrees. This will be my angle beta, right? It has to be a positive angle, which is why I'm adding 180 there. So now I have this angle to be 104 degrees, which means I can calculate this angle. So I'll say 180 minus that angle, I'll get UT 180 minus 104.04. I'll get UT, this is 76. Let us call this angle theta then. We'll get theta to be equals to 180 minus 104.04 degrees. We'll get UT, this is 75.96. Right? So this is 79.96. Now we can calculate the angle ABC. Angle ABC will be equals to 180 minus 45 minus 75.96 degrees, which will be 59.04 degrees, right? This will be 59.04. Okay, so yeah, I think we'll stop here for now, and then maybe do a few past papers, and then when we continue with the lessons on analytical geometry, we will look at circles in analytical geometry. right? So after this, I'll just look for past papers that we can do, and then yeah, we'll take it from there.